Okay, so we're going to continue on with our factoring lecture. Hopefully you have your factoring lecture handout so that you can follow along. We did the first 5 problems already. Now we're going to do the rest of them on page 2. X squared plus 3x minus 10. Again, we're factoring. There's not a number in front of x squared, so if you want to take your shortcut, you can, where there will be an x and x. I like to draw my t-square anyway, just so that I can really see visually my factors, because I am a visual person. How about 2 and 5 with the 2 being negative? Now on these you should kind of check and make sure that that makes sense. You don't FOIL it back together. With factoring by grouping, you don't really have to FOIL it back together because you check each little step. This one has an a squared at the end, and I could take a shortcut on this one, but I think I'm going to factor by grouping just to show you that you can indeed do it either way and get the same answer. For factors of positive 6 that add up to be positive 5, let's use a positive 2 and a positive 3. When I rewrite the expression using these two factors, I can see that I then will have to put parentheses around the first two things, last two things, take out what you can from the first one, which is just an x, so you have x plus 2a, and then you can take out a 3 and an a from the second set, and you have x plus 2a. And then since the inside pieces are the same, you can drop them down, write them once. I'm kind of out of room, so I'll drop them sideways and write them once. X plus 2a, and then the outside piece is x plus 3a. And in our shortcut, if we had been clever, we would have got the same thing. Some of you might have been a little hung up on that a squared thing, which is a good idea to do it the old-fashioned factoring by grouping way to avoid any kind of mistake that you might have made with that. The next one, so always start with your t-square. 6 times 36, that's a really huge number. Let's just take out what we can before we start. I can definitely take out a 6, I can take out an x, and it looks like I can take out a y as well, and that might help make this trinomial easier to digest. So we would have an x squared term, and then we'd have a 5xy, I believe, and then we would have a plus 6y squared. Now that's very similar to what we had up here. So this should factor into x plus 2y and x plus 3y, theoretically. Checking it in my mind, sorry. Yes, that looks good. Okay. Anytime something can have a factor pulled out in the beginning, do it because it makes your life easier. This one, nothing can be factored out in the beginning, so we'll just proceed with factoring by grouping. We want 2 times 4, which is 8, factors of that, which add up to be 9. How about 8 and 1? So we have 2x squared plus 8x plus 1x plus 4. Draw parentheses around the first two things and the last two things. Take out what you can from the first set. We can take out a 2x. We'd have an x plus 4. From here, it doesn't look like there can be anything that is taken out, so take out a positive 1. You have an x plus 4 left. Insides are the same. Drop them down and write them one time. Connect your outside pieces. So you get 2x plus 1 times x plus 4. Hooray, hooray. Alright. Next one, same thing. 3 times negative 2 is negative 6, adding to be negative 1. How about a 2 and a 3 with a 3 being negative? 3x squared, let's switch it up a bit. Minus 3x, write it out of order. Plus 2x minus 2. Draw parentheses around the first two things, the last two things. Take out what you can from the first set. Take out what you can from the second set. the inside pieces are the same, which they are. You drop them down, write them one time, connect your outside pieces to get 3x plus 2 times x minus 1. And you're done. Always go along in the same fashion. Factoring by grouping really isn't that hard. 8 times negative 3 is negative 24 that add up to be negative 10. I'm going to guess 12 and 2, with the 12 being negative. So we have 8x squared plus 2x minus 12x minus 3. Parentheses around the first two things, the last two things, take out what you can. Let's take out a 2x to get a 4x plus 1 left on the inside. Here on the second set, take out a negative 3 to get a positive 4x plus 1. Watch the signs there. If you distribute back, you have to get what you had, so it has to be positive 4x and a positive 1 there, because a negative times a positive makes a negative. Insides are the same. We're going to drop them down, write them one time, and we'll connect those outside pieces and be done. So we have 2x minus 3 times 4x plus 1. Next one's a little bit out of order, so let's write it in a descending order to make our lives easier. 12x squared plus 36x plus 27. These are big numbers, so I bet that we could factor out something, and that might help make our lives easier. Definitely can take out a 3. We'd have 4x squared plus 12x plus, what is that, 9? That might help a little bit. 4 times 9 is 36 plus 12. About a 6 and a 6. So we get 3 times 4x squared plus 6x plus 6x plus 9. This kind of feels like a perfect square. From the first set of parentheses, I can take out a 2 and an x, and I'd have a 2x plus 3. Second set, let's take out the positive 3, and we'd have a 2x plus 3. Insides are the same. We're going to drop them down, write them one time, connect the outside pieces, and it is a perfect square trinomial. Sorry if my hand was in the way the whole time. I forget. Okay, perfect square trinomials. There's a formula on the first page. These guys here. Your linear factors are identical. So that's what makes it a perfect square, is the linear factors are identical. 2x plus 3 and 2x plus 3 identical. So it's a perfect square trinomial, that one, times 3. Okay, last one on this page, and then we'll move on to the next page in the next video. Hopefully you've already started. We want factors of 6 that add up to be 6. That's a little bit difficult. Thinking, working. I kind of want to say it's not factorable. Can you think of anything that factors of 6 that add up to be 6? I can't really off the top of my head. 2 times 3 is 6, but 2 plus 3 is definitely not 6. So I don't think that one's factorable. And that's okay. Sometimes you get ones that just cannot be factored into linear factors. It's not a big deal. And remember that just because something isn't factorable doesn't mean that you couldn't solve it if you were required to. If this was set equal to 0 and it said solve, we couldn't solve by factoring, but we could solve by the quadratic formula or perhaps completing the square. Alright, next video will be the last page of the factoring lecture.